present and the unborn generations of the United States and the world are heirs to one of the greatest energy discoveries of man, nuclear energy. Accompanying the tremendous advantages of this discovery are certain potential risks to health and life. As small as these risks are, the government has the responsibility of assuring that the health and lives of people are protected, while the advantages of nuclear energy are being developed. Nuclear energy has already been put to use in many ways, as a source of heat for production of light and power. In cities, in industry, and for the propulsion of ships. It is used for experimental purposes in agriculture and to develop stronger strains of disease and weather-resistant food crops. Another great area of development for nuclear energy is, of course, medical research. Radioiodine has been found to be an effective treatment for hyperthyroidism, to give but one example. It is used for the control or relief of some diseases, and these uses will, of course, be greatly extended and improved in time. New programs of the Atomic Energy Commission and other agencies are designed to expand the usefulness of nuclear energy. Before work is begun on any of these programs, the government thoroughly evaluates the health and safety factors, often for several years, until it is assured that the project. Three major programs planned are: 1. Aerospace nuclear reactor tests. 2. The Plowshare program for the peaceful uses of nuclear explosives. And 3. The Seismic Research Program for the detection of underground nuclear detonations. The first of these programs, the Aerospace Nuclear Reactor Test at the Nevada Test Site, includes the development of a nuclear engine to propel rockets into outer space, and the development of a reactor for use in a nuclear ramjet engine to power a vehicle at supersonic speeds within the atmosphere. The Plowshare program covers several different fields. One is the development of a new source of power to supplement the rapidly diminishing supply of oil, coal, and gas. Today, reactor plants can provide an alternate source of power from nuclear energy. However, this power is now expensive because of the initial cost of the plants. In the Atomic Energy Commission's effort to find additional sources of power, one of the Plowshare's experiments involves investigation of the problems in the underground storage of heat produced by nuclear explosions, and the recovery of this energy to provide electrical power. Industrial expansion. Other objectives of the Plowshare program are to study the possibility of producing isotopes in these underground explosions, to aid in the economical recovery of minerals upon which the expanding industries of the world depend, and to explore safety techniques and economic feasibility of using nuclear explosions for excavation purposes in the building of harbors and canals. The Seismic Research Program is designed to improve methods of detecting and identifying underground detonations by seismic recordings, and to determine the wave ray patterns in the immediate vicinity of the site and at other stations in the seismic network. To differentiate between underground explosions, earthquakes, or subterranean tremors of similar intensity is a major difficulty. In the development of the Seismic Research Program, it is necessary to determine the characteristics of the seismic waves from an underground nuclear explosion at seismic stations all over the world. The Department of Defense plays a primary role in the Seismic Research Program, with full assistance of the Atomic Energy Commission and other agencies. In the selection of an underground test site, a series of test holes are drilled in a predetermined pattern. Known quantities of chemical high explosives are placed in the test holes and later detonated. Mobile seismographic units stationed at measured distances from the test holes pick up and record the resulting shock waves. Seismic recordings of the Earth's underground tremors are made from each detonation in the test holes. Here, the explosion was made by chemical high explosives relatively close to the surface. Seismic recordings produce considerable data on the underground geologic strata and hydrologic formations. These data contribute to the final site selection before preparations are made for nuclear detonations. In seismic research and other programs where the explosions are deep underground, no radioactivity is expected to reach the atmosphere as a result of the detonations. But the possibility that radiation may vent through cannot be overlooked. Safety precautions, such as collection of water samples from deep wells at the site area and from private wells and other water sources, will be used to determine if significant contamination reached water supplies. Health and safety precautions to protect workers at the site will include the use of film badges and monitoring for possible surface radiation. For the protection of the people in the vicinity, ground crews will monitor for radioactivity in adjacent communities. And at nearby facilities before and after each test. In implementing the three programs and to accomplish their objectives, the Atomic Energy Commission is coordinating the Public Safety Program with the Public Health Service, Weather Bureau, Geological Survey, Coast and Geodetic Survey, Bureau of Mines, and various other agencies. The efforts of these agencies, together with those of state health departments, form a giant network that protects the health of the people. The Public Health Service off-site radiological safety staff provides radiation surveillance support for the nuclear energy exploration programs. This support requires the cooperation of everyone involved. It requires taking every reasonable precaution to safeguard the environment and health of the people who might be within the range of radiation effects from tests. Officers of the Division of Radiological Health of the Public Health Service are concerned with the broad spectrum of health problems related to nuclear radiation. They are assigned to various activities and participate in nuclear energy exploration operating programs. The Weather Bureau acts in a staff capacity to provide data on pertinent weather and meteorological conditions. It predicts surface radiation patterns prior to the test. In fact, right up to the last minute before the detonation. Pre-test weather briefings consider the possibility of downwind, rain, or snow, the wind direction and speed at various altitudes, and high and low pressure areas. Although the possibility of radiation escaping from contained underground nuclear detonations is small, a close check is made on meteorological conditions as an additional safety precaution. In concert with the Weather Bureau in this capacity, the Public Health Service provides the Atomic Energy Commission with data on the actual measurements of the surface radiation field and patterns, and how they may have deviated from the predicted estimates after each event. The U.S. Geological Survey plays an important part in nuclear energy exploration programs in the investigation of the technical problems relating to the selection of a site which will provide maximum safety for the public. Special emphasis is given to the location of water-bearing strata. Samples of rock, ore, and minerals are collected from the site area and examined to provide data on the underground geological strata and formations. Geologists also take water flow measurements in strata surrounding the proposed test area and advise on the relation between surface and groundwater. The Coast and Geodetic Survey also assists in providing recorded data on seismic vibrations emanating from underground explosions in the Plowshare and seismic research programs. The seismometer is activated by the ground motions of varying intensities. The seismograph records the earth tremors from both underground explosions and earthquakes. The seismogram shows the magnitude and epicenter of the earth tremors. The Public Health Service radiological staff and the Atomic Energy Commission conduct an extensive public information program to educate civic groups and other interested organizations as to the nature, purpose, and procedures of the radiation safety program. This public information program informs the people in the vicinity of the test area of the objectives of the test project and its potential, probable, and actual hazards. They are also informed about the many safeguards and precautions designed to protect them from radiation exposure, and advised how air filters and appropriate counters will indicate any concentration of radiation in the area. The people are informed about the film badge program and shown other devices for measuring radiation in their vicinity. They are told about Geiger counters and other radiation detection instruments. All communications media are utilized: newspapers, radio and TV stations, and other communications sources. The public is continuously informed, to the extent of its interest, as to the operations and developments, and advised as to the success or failure of the project as related to its original purpose and justifications. Public information programs include informal discussions with public officials, school authorities, and other groups. Through liaison and appropriate communications with state and local health officials, the radiological safety program is augmented by their interest and participation in the program in their respective communities. This state health official is observing the safety precautions used for measuring radiation levels at a test site in his state: Geiger counters, continuous recorders, air sampling units, and fallout trays. Where experimental tests are undertaken, continuous radiation recorders are operated in selected communities near the area. These recorders will measure the natural background radiation and are capable of automatically recording the time of arrival, intensity, and length of stay of any additional radiation. In other locations, monitoring teams collect exposed air filters periodically and send them to the off-site laboratory, where appropriate counters will indicate concentration of radioactive particles on the filters. Aircraft equipped with monitoring devices for radiological safety surveys are available and will be used as necessary to monitor up to a distance where the radiation is no longer detectable. In coordination with these aerial surveys, Ground crews will make surveys in the area if the need arises. This is true if the community consists of only a few, or of hundreds or thousands of persons. Film badge stations are set up over a wide area. The film badges provide a cumulative record of external gamma radiation exposure. Exposed film badges are collected and replaced on a specific schedule. And records are kept of all radiation exposure. Other monitoring operations include the sampling of foods indigenous to the area, the sampling of soil in the vicinity, of milk produced in the area, of potable and other water supplies. At the Public Health Service Radiological Health Off-Site Laboratory, the environmental samples are prepared and counted for gross activity. Emphasis is given to water samples from underground sources. Radioanalysis is undertaken on an intensive basis for 1 year, with follow-up for 5 years. When indicated, samples are examined to determine specific isotopes, either by radiochemical separation or by gamma spectrometry. Several types of counting instruments are used for measuring radioisotopes. This gas flow counter automatically determines the radioactivity of each sample. Fallout trays are read for any radioactivity. Air filters are checked for radiation count. After the laboratory analyses comes the task of correlating and analyzing all data relating to each test. This comprehensive summation includes negative data associated with the operation and recommendations for future experiments. A public health service physician who is part of the Medical Liaison Officer Network is assigned to the Radiological Safety Organization. His primary function is to consult with local physicians and medical societies to answer any of their questions on the biomedical effects of radiation. At the Nevada test site, on a continuing basis, a veterinary officer is assigned to the radiological safety staff. He is available for consultation with private practicing veterinarians and farmers at other locations. His primary function is to advise local veterinarians and ranchers about the effects of radiation on livestock. An extensive animal study has been in progress for several years to provide data on the uptake of radioactive isotopes. In keeping with these studies, a test herd is allowed to forage at the Nevada test site in areas where there are known fission products. Animals of both sexes are sacrificed periodically. The thyroids are examined for the presence of iodine-131, bones for strontium-90 and plutonium, and muscles for cesium-137. Also, pathological examinations are made on selected specimens. Results to date show no significant gross effects or diseased conditions which suggest ill health or lowered resistance. The Public Health Service, in cooperation with the Atomic Energy Commission, guards the public health by continual and constant surveillance and by thorough assessment of possible hazards prior to the authorization of each test. All known preventive measures are used to restrict the radiation exposure to an absolute minimum. With the many safeguards and precautions taken in these program operations, it is unlikely that the public will be exposed to radiation levels greater than the protection guides recommended by the Federal Radiation Council. Through nuclear energy explorations, man will continue to learn more about this new source of energy and to apply it to an ever-broadening horizon. At the same time, the health and safety of people everywhere will be assured by a continuing realistic radiation surveillance program. Our future generations deserve a heritage of greater freedom from want and care, and confidence that nuclear energy will contribute to the establishment of universal peace.